we had the very initial inklings of building something that could sit on your desk, software that ran on a personal computer. But the technologies to build that with were pretty arcane and have stayed so for a long time. These are from everything from your own hand-rolled C++ applications to some Java apps or GTK or WPF systems. And there has been this dream of the web of taking the ideas and technologies and stacks that this audience is familiar with and putting it on the desktop. Moving forward to only 145 million seconds ago was the birth of this project called Node WebKit. The idea of dropping a Node Chromium-based frame and down there on the desktop and letting you build a web page into it. A little while after that, the Atom team from GitHub actually took one of the original Node WebKit creators and themselves created their own desktop framework to power their Atom text editor, which they named Atom Shell. And finally, only last April, 36 million seconds ago or so, this got rebranded into Electron. And Electron is what I'm here to tell you about today. In case you haven't seen what Electron can do, Electron is the tool that lets you build an application, drop it straight down in your dock, and launch it like any native feeling application on Windows, Mac, or Linux. This is an email client that I've been working on, but under the hood, it is powered by JavaScript. This has access to everything that you would expect a normal DOM to have, plus a lot of all of the node.js libraries that you would expect to have with it as well. And combined, they create this desktop experience to let users use an application like this without even realizing it's built with modern web technology. And that's really what I want to talk about today, is how these applications come around. I'm going to start off first by talking a little bit about how Electron is built. Show you 5 pretty cool things you can do and build with this type of environment. And finally, talk a little bit about why I think this particularly matters now going forward for this community. So Electron, at the very high level, at the end of the day, is latest Chromium and latest Node.js smashed together. It means you have the tools and capabilities of all of these platforms in one development environment. To tell you a little bit more about how that actually works in detail, first I want to talk about Chromium, the browser that we're all familiar with using. Chromium has this back-end browser main process, which is a huge glob of C++ code. It's not particularly easy for us as JavaScript developers to access that, but it is responsible for spawning all of these individual renderer processes. You colloquially know them as individual Chrome tabs. They're totally isolated process web environments that have their own piece of HTML and JavaScript engines in them. And until recently, that used to be pretty much our entire world as web developers, one of these green boxes. What the Electron team ended up doing is they replaced this huge glob of C++ with Node.js, and also put Node.js in each individual renderer process. The details of how they do that are actually pretty cool. One of the more complicated pieces about this is how to merge these 2 completely independent environments together, particularly dealing with the event loop. In Node, we have libuv, which is the event loop that keeps track of all the processes in your and your next process and everything like that. And Chromium has its own completely separate message loop as well. And there were early attempts by Node WebKit to try and inject a bunch of code inside of that Chrome message processor as well, but that turned out to be pretty hairy. It means you need to recompile Chromium, which is not particularly nice. So for all of us, what they ended up doing was dropping in their own dispatching system that effectively strings them all together. What that means at the end of the day is that it leaves us as developers a really nice environment where you can seamlessly use any of your familiar node techniques as well as everything that's in the DOM together in one environment. To sort of illustrate how this all flows together, let me concretely talk about how you would boot up an app. Like, for example, this email client I've been working on. One of the nicest pieces about Electron is you now have access to this whole backend process. Our app starts with a single main.js file. And here we're given access to our own, to an Electron API that boots up in an individual browser window, one of these tabs. Having that process control means that we can not only boot up our own application, but also separate windows as well, which is a technique I'm going to show later that's particularly cool for performance and optimizations. But once the application starts up, you have what you're familiar with. That entire application is a single index.html file with a single index.js file to boot up from. And in our case, we're using React to render all of our individual components. But it's at this point, you just have a web frame with the added benefit of all of the Electron APIs and Node at your disposal, plus these additional windows, which we use for things like our pop-out composer or for these separate worker window processes. Pulling all of these pieces together, now you've sort of seen that Node and Chrome in this mashup lead to a handful of particularly nice pieces that really make this a much more interesting development environment, and one that can finally, in my opinion, really make a native first-class feeling application on the desktop environment with JavaScript technologies and all of the tools that we have. And one of the biggest things to make a compelling application is having this very compelling native feeling experience. One of the issues with applications in a frame like this before was this uncanny valley. It wasn't quite native. It kind of felt like a web page without the frame around it. And actually, if you notice, there are several applications where if you right-click, you get back or reload as your only options. But with Electron, that's one of the nicest pieces about this are some of the extra APIs they give you to make this slightly more native feeling experience. These are things like having a native right-click menu that you can control that uses native controls. It means also having APIs to display native notifications as well, which would work if this was not off. And native notifications that work on Mac, that work with the native Windows taskbar. It's a lot of these subtle pieces like this that really help pull applications out of this sort of uncanny valley of feeling not quite there or not doing the pieces that people expect an application to do. Right-click, for example, is a huge deal for Windows users who very much expect this. In addition to pieces like having APIs to put your controls up in the toolbar here, there actually are even several Electron apps who are nothing but a little toolbar up here in the top. So it gives you a lot of flexibility for that too. The second piece about this native feeling has a lot to do with the look and feel for it. And the answer to that so far has actually been CSS. Everything here is styled with regular CSS with the added benefit that there's no cross-browser compatibility. If it looks right and it works in latest Chrome, you're done, which is a really nice environment to work with. Modern Flexbox is actually a very sophisticated layout engine when it has a consistent implementation. It also means that you can do tricks like style everything down to the stoplights yourself with CSS, or use techniques like we have a half-pixel box shadow around the buttons to give you a true 1-pixel retina border to match Mac standards. And finally, then can do styling not just for Mac, but for Windows as well, all with CSS. Now, when we started this project, Electron and Atom Shell were particularly new, so we ended up rolling a lot of these components by ourselves. But at this point, there are very sophisticated UI kits that out there that for all sakes and purposes, you cannot tell the difference between the exact pixels you're seeing with CSS and what you would expect a native application to do. Plus, being able to have native Mac hover tooltips and extra pieces as well helps with that UI experience. A lot of these put together eventually end up helping you build an application that does feel native. One of our goals when people install this application is that you don't have any idea that it is built on web technology. It feels as robust and first class as anything else that might be in your dock and start menu, but it is something that we as developers can build very quickly, and crucially for our product allows other developers to build plugins on top of that inside of this ecosystem as well, which is exactly the goals of Atom, the text editor, when they set this all up in the first place. That native experience, these details are one of these pieces that you finally have with Electron. There's pretty much no API that you would see a native app do that you can't now do with Electron. Not to mention, of course, it's open source. We've also contributed back things like Max swipe gestures and things like that. But by now, that feature list has gotten extremely well filled out. Another very powerful thing that you have is process control, largely thanks to Node.js. I can actually require the process library from here and spawn processes via Node directly from even these renderer frames as well. And one of the extra powerful pieces about this is then being able to compile native extensions that you can access from the application. So in our case, we ship a full SQLite database with the application that we can just use and install through NPM. There is one minor piece that the Electron system has in order to make this work, and they have a tool that's called Electron Rebuild. Basically, all that does is that it compiles it against Chromium's headers instead of Node's headers. And now that's largely entirely abstracted away from you because of Electron Rebuild. But under the hood, it's even not that complicated for those that have been using NPM for a while. Under the hood, it just calls NPM Rebuild with a couple target and architecture flags, and then uses node.js under the hood to actually compile it. So before we ship to any platform, we run these steps. Node.js goes and actually compiles it for all of our Windows and Mac platforms. And then we ship an app with native extensions. Having that type of process control is particularly powerful because it really means that even if you get to the very end of what the web can offer, you can still drop in something else on the side. We have some friends that are building an application that have an entire Haskell process running on the side. You could compile your own piece if you really, really, really wanted to, and load it and run it from this environment as well. It also emphasizes how much control you have over this unique environment. It's everything you'd expect Node to be able to do, plus with the UI components on top of it that make it really nice. Another huge benefit about this tool is actually the performance of it, which is interesting because whenever people think about JavaScript on the desktop, performance is always something that comes up, especially coming from a world of hard compiled applications. But performance in Electron comes from a couple places. One of them is straight from your standard web profiling tools. We make very heavy use of Chrome's profilers, flame charts, debuggers. And we actually kind of take this for granted as web developers, but these tools are incredible. The amount that it can, finding the ability to see every single paint cycle and have these flame charts and have these types of debugging tools is quite rare in software development anywhere, let alone the desktop. And at the end of the day, to a user, performance is just whatever's moving at 60 frames per second. Well, these are remarkably powerful tools to help you see that kind of performance and really make sure that things are running at that speed. Another great part about these tools is that they're always upgrading, thank you, Chrome. Every time Chromium bumps their dev tools, it shows up in Electron a couple weeks later, and we get all of that benefit. The tooling ecosystem around making web applications fast is extremely lucrative for us as developers in this ecosystem, and it's something that you can take full advantage of to make something run at the end of the day at 60 frames per second. Now that being said, there are still several limitations that you just can't get around even now. One of them has historically been this sheer single-threadedness of JavaScript. Luckily, that is also drastically improving with web workers and service workers, and even some crazy multi-threading experiments by Mozilla. But Electron also has a nice trick that we use, and a lot of other people use, and that's actually just to spawn an entirely separate worker process. This is an entirely separate renderer process that we can launch from our backend, and its job is to do nothing but parse megabytes and megabytes of JSON and deal with tasks and keep things queued, keep them offline. But it means it's effectively a service worker, but unlike a service worker, it has its own interface and UI to it, which in our case is useful for debugging. But it also is important because things like text layout don't work properly in web workers, which has been a huge issue getting like React's virtual render moved off the main thread. In Electron, you can do that. They talk to each other through a standard IPC bridge, so you do have a limitation to whatever you can stringify. But it is very fast, and in our case, they can all talk to the same SQL database. These are truly independent processes running on completely different cores that can help get around this fundamental issue that if you're doing a lot of processing when you're scrolling, your scroll's going to jank a little bit. Once again, this has its own independent set of performance tools as well, and an entire, because it is just, in fact, another Chrome frame. So between a lot of these techniques, between everything you can read on the internet about jank-busting websites, in addition to the parallelization you can get off of Windows, performance is actually an extremely attainable goal in very rigorous conditions with this platform. In our case, our biggest concern was just dealing with a huge amount of data. We're syncing gigabytes of mail at any given time locally and indexing it and searching through it. But being able to offload these processes is something that can really help move that forward and make that efficient. And as a result, between these two factors, you have an app that you very much is in your power to make as performant as just about anything that you would see on the desktop, including, I think you can probably think of some apps on your desktop that may not as be performant as you would like them to be. Plus, once again, like a lot of the performance improvements and memory usage that we get from V8 also come along with us as well, too. One of the biggest pieces about being able to deal with all of this persistence, make it work offline, is our ability then to store data locally on the system. I showed before that we compiled this SQLite database for us, and here you can directly access that easily with code. This is from the console, having a query to load 34,000 contacts from disk nearly instantaneously. And that sort of synchronous control to a database that you have right there is really powerful, both in terms of data patterns, but also for offline persistence as well. As you can see, I'm offline now, but all of the tasks that I would want to do can get queued up and cached locally. Even if I quit the app and open it again, there's some place real that I can persist it to disk. We tried at the very beginning to use some types of web SQL or do some crazy things with local storage. But at the end of the day, because you have this file system access, because you have process control, you have much better options in types of persistence methods you can use for your application, which means that we can store a huge amount of data, we can make sure it works offline, and then we can access it immediately from disk. which actually leads to a pretty fun data pattern that we like to use that basically lets us pipe a SQL command or some piece of data straight down to React view. We make heavy use of observables through the reactivex library, which I would highly recommend checking out. It basically means that I can write a piece of code that looks something like this. I have a query, right? I want to show some threads where Dinosaur is something. You set up these observables and you subscribe to it, which means that anything that matches this query at any time will update the view. With the additional benefit that with reactivex I can filter it, I can map it, I can debounce it and reduce it. But it's an extremely robust way to pipe data straight from a database down to a bunch of components, which is crucial when we have tons of data that need to go to lots of different components. With this type of pattern hooked up straight to a database, it's a really nice way to be able to load a huge bunch of threads depending on the current view that I have, and do so very robustly as well. Once again, this is another nice thing. You certainly use this pattern with any other data source, but in this Electron environment, the fact that I can hook it up straight to these live queries is a really nice thing to be able to do on a front-end application, especially when a framework like React is sitting at the other end to take these updates and have everything declaratively wired together. And then finally, one of the biggest reasons why we're on the desktop is actually the same reason that Atom the text editor is. And that's because it lets us build an environment that is extremely extensible and supports a lot of plugins. And in our case, we use those plugins to extend what you can do with email. So for example, I can start off a basic composer with really no added functionality, but then go into some settings here and add a plugin that lets you type emoji or schedule something, quick replies, translate, do encryption, read receipts. And I can load these from disk and then at runtime inject them straight into the system. So now all of a sudden my composer can find my key, verify it on Keybase, then use a template that drops it in with some extra emoji inside of here, plus templates, and then finally encrypt it all, and then send it. And these are all completely independent plugins that we can install and uninstall at whim at runtime, and largely thanks to the ability to have the access of the file system to be able to load it in and dynamically inject everything. This has also been a huge boon to building this on top of a React-based ecosystem, because in our case, we can define all of these different regions around the application where you would want plugins to be able to extend things. And we treat these React components, these plugins, as data. We can load them from these stores and render them in wherever they need to be, which is a really nice way to help keep things a little bit more tidy, as opposed to the traditional model where you sort of jQuery yourself into the DOM and hope for the best. So this is, once again, another very nice piece about not just what React can do, but also pulling it together in a full desktop application. And it's a type of place where people expect to be able to not only extend the functionality they're working on, but also develop them themselves as well. So we found that this type of environment gives you a lot of plugin control, and it's something that we very much modeled ourselves off of Atom the text editor for. And as a result, much like Atom, this project is also open source, because a lot of the different data patterns that I showed here are definitely things that we want to share with the community as well. And having this type of project open source, like there's now finally there are an increasing number of applications built on Electron that are out there that are becoming examples off of. We hope this can be an inspiration. But to start off with, I would highly recommend looking at the very fantastic documentation the Electron team has provided. thanks to the efforts of GitHub, including this super easy to use Electron quick start as well. So that's sort of a lot of the different pieces, at least 5 reasons why I really like this application platform, the types of things you can do with it. It means you can get over that uncanny valley. You have access to any process control you want. It's highly performant. And it comes with a lot of integrated pieces that would otherwise be very difficult, including a system to auto-update your app, do these native notifications, have access to the file system. And it's really helped us build this, in our case, this application to allow this extensible email client, or to build, for Adam to build a text editor that's hackable to its core. And also just on a day-to-day perspective, before this I came from building an application that supported IE8 and Backbone and jQuery and mobile browsers. And the fact that you never need to worry about browser compatibility when building these applications is an enormous, just day-to-day source of happiness for me personally. Which sort of leads me to finally thinking about where this is going, why this matters. The desktop is an interesting environment, right? It's kind of this thing on the side, especially now with the development of how powerful mobile apps are becoming, and the focus is there. But at the end of the day, desktop is still overwhelmingly where real work is getting done. It is where people are spending 8 to 10 hours a day in front of 30 inches of screen in order to do a lot more of these powerful applications. That type of environment is very much still going to be around, but until recently has been fairly significantly underserved. And I think a large part of that is because it's very difficult to build an ecosystem around that doesn't have any of these cross-discipline toolings to take advantage of. And it's one that hopefully tools like Electron will, and this audience here, will help fix in the immediate future. Another piece about the desktop is also a different type of place that it has as an application in somebody's workflow. There's something a little bit different about when you have this core application that you launch from the dock that is open with you all day long, that you're very much invested in using it. It really makes, when you think about the time in app for a lot of these applications, it's certainly worth thinking about as a place to be, especially when it's as easy to build with the tools that we have available to us as well. The number of desktop applications being built on this is growing quickly. It's not just us, Slack, Visual Studio Code, the Microsoft team has invested an enormous amount into this ecosystem, and it really shows. And many more increasingly along the way, and hopefully a couple more in this audience soon. I want to close by, of course, thanking a team that worked with me in order to put an application like this together over the past year. And we'll be around to answer questions and hopefully get you even more excited about building these types of applications. Thank you very much.
I have to say, personally, I'm very everything should be done in the browser, and then we can push people to improve browsers so that we don't have to have desktop clients. But the plugins and extensibility, I feel is the real clincher, because I use Atom when I'm not using a CLI editor, and just the ability to be okay, I'm working with this language, so I'll just see if somebody had made a syntax highlighter for that already, which is really cool. What is your favorite Electron app?
So of course I'm a little biased being in this community all the time. I mean, Atom is a fantastic one. Visual Studio Code I also definitely want to give a shout out to. That is an extremely impressive application, and especially when people were very concerned about speed at the very beginning when they were working on this, Visual Studio Code came and really showed how fast you can make this. Also, the amount of effort that the Atom team has put into making that application fast is also very impressive.
So the thing with Electron is that sort of the onus is on the user's machine to have Node, and Node is still kind of a touchy thing for mobile, and I assume television. Is there a sort of roadmap to get Electron apps on devices that allow you to install desktop apps?
Yeah, there's certainly, right now I think they're very focused on sort of your core Windows, Mac, and Linux platforms as opposed to these types of embedded systems. That is one thing. Electron does come like at the very base level with Chrome and Node in it, which does have a certain amount of getting started size to come with, but as a result, they do install extremely reliably. There are no extra side dependencies that you need on the systems, and they will go and auto-update on each platform independently. But they're probably going to continue focusing on these environments, especially with how well, other tools like React Native have done on mobile, and even what mobile web has been able to do recently too.
This is a true or false question. The native feel is the fold of our generation.
The fold? TBD.
You know what I mean? The fold where everyone's like, oh, it has to be above the fold. And now people are like, oh, it has to have that sort of native feel. It's what we want. It's just a fake idea, I feel like. Maybe that's a controversial statement, but.
Yeah, it depends. I think it depends. So Spotify is my favorite example of someone who, on one hand, is definitely running with their own piece. Yeah, I think it depends on the type of application that you are, sort of where you fit in pieces. I do say that a little bit of native kick really helps get around the feeling that you're sort of looking at a web page without any Chrome controls to it. So it definitely helps people buy into it immediately and feel like it does in fact belong there with the rest of your applications.
Do you think that this combats the progressive web app movement?
Different place. I think there are definitely still a lot of things you need in your browser, and it certainly makes a lot more sense for mobile reach as well. This exact code base will likely never exist on a mobile app. We can share certainly a lot of the core backend pieces of it, but it is going to be a very different experience.
Cool, thank you very much. I have a feature request for N1. I don't want mail.app to ever open on my desktop, so if you can add a blocker for that into your client, that would be really excellent. Thank you very much.